Hello, everybody. I'd like to welcome you all to this month's webinar. We're going to be talking about circular design in the electronics industry, discussing case studies from a life cycle perspective. And with us today is Karsten Schischke from the Fraunhofer IZM. And Carl is passionate about making the electronics industry more sustainable. For more than 20 years, he found life cycle assessments boring, but is thrilled by the design, business, and policy solutions derived from solid LCA evidence. He's leading the group Product Eco-Design and Circular Materials at Fraunhofer IZM, a leading institute in the field of applied research for the microelectronics industry, and supports his team, industry, and governmental bodies alike to keep the 1.5-degree target alive. Also with us is Senior Sustainability Advisor Tom Etheridge, who will be asking your questions for you at the end of Karsten's presentation. So you put them in the Q&A, and welcome, Karsten.
Yeah, thanks, Holly, and thanks for having me, actually. So I'm happy to talk then a bit about past experiences here with circular design related approaches and the life cycle evidence also we have. So I will draw evidence from some design examples, from some product examples. First, some of our own examples, later on then from a great INEMI project we have had last year, actually, which also provided quite good insights in how industry approaches circular design. But first of all, for the introduction, Holly told you already quite a lot about myself. I will build on this. So this here is a family picture. So actually, the youngest kid here on this photo is my grandma. Right behind her, her grand-grandma, a lot of her sisters, so all of them here in a small village close to Berlin. This photo was actually taken 110 years ago, and I still had the pleasure to have met most of the people here on this photo. So in the meantime, all of them have passed away. But the shocking thing is, it's so long ago, 110 years, almost at the same time, this article here appeared in Popular Mechanics. You might have heard of that article as well. So it's now and then circulating on social media as well. So the first broader mentioning of the greenhouse gas effect and that what has been emitted will change the climate within a few decades. This is here a really early warning, and since then, a lot of time passed, but here we are with the Paris Agreement, and not fully sure if we'll meet the target, or rather, very likely that we fail somehow. What are we doing here now to speed up a bit in that instance? My background is the Fraunhofer IZM. We are doing mainly electronics research, microelectronics packaging, making things smaller, more reliable, sometimes working with novel materials, stretchable materials. But in the end, also trying our best to make things more sustainable from a product perspective. That's partly then also mirrored by cost aspect, of course. So we cover a broader range of medical engineering, industrial electronics, the automotive sector, of course, the ICT sector frequently when it comes to environmental issues, because there's a lot of the environmental investment in these aspects. And as Fraunhofer is typically not so well known in the US, we are placed here in between basic research, which typically here takes place then at universities and some other large research organizations, and the pilot line mass production developments, which are taking place then in industry. So we are doing quite a lot of research actually for industry. 300 people of us working on getting the processes right, on developing technologies, and around about 30 researchers working on environmental issues, on sustainability issues in electronics, frequently then in a broader sense, covering the whole product. And we also try to support then policy making with our advice, which we gather from our technology insights here. So let's come first to some of our own projects where we are involved and the circular design of electronics. So this here rather than the backup slide. I don't tell you anything new, I guess here. So that the main target is to keep things in the loop. But you should be aware, if you're in the electronics sector, these inner loops are of utmost importance. If you make some kind of life cycle assessment calculation and try to improve here the outer loops, the recycling loops, you will all of a sudden see that this doesn't help you much. You get small credits for it, but most of the environmental impact is really coming from the production of the electronics, and it's not necessarily the material, it's really then semiconductor processing, it's the printed circuit board manufacturing, such kind of processes, and then this is wasted once you come back to the recycling processes. You should do recycling, so no doubt about that, but it will not help much to improve the life cycle assessment dramatically. We worked here with a European small company, Fairphone. They started to develop in 2013 a fair smartphone, then with a second generation going for a modular one to make it better repairable. We have been assisting them now over the last 3 generations with life cycle assessments of these products. And when you quantify the carbon emissions, first thing you notice is that it's indeed all in the hardware, mainly in the production phase. Most of it, what is here, the core module, then the electronics, storage, CPU, all the radio interfaces, the chipset for that, and much less for other parts and components. So 5% only for the display, another 5% for the battery. But typically, these are the parts which fail in such kind of cell phone. So you have to replace the battery, you have to replace the display and keep the rest alive, hopefully. Also the environmental investment you had once here. So that's why it's so super important to build such kinds of devices, then modular, to be able to exchange these parts here. But there's also a certain environmental overhead. When you develop such kind of product in a modular way, you need additional connectors, you need additional printed circuit board area, additional sub-module housing. So this all adds up. So once you have the device in your hand for the first time, the environmental impacts are higher than for a conventional design. All this pays off then only over really a longer use. So that you indeed repair it when it's broken, that you can do that. And we quantified this here then also comparing it per year of use. So it's the functional unit, 1 year of use of such kind of device. And of course, if you can go further from 3 years to 5 years to 7 years use with certain replacements of certain parts, you bring your impact per year of use down here. So this is the main intention here, and it works pretty well for such kind of device for a smartphone. We tried this approach then also for other devices here, a digital voice recorder. Yes, these products still exist for lawyers, for staff in hospitals, for journalists as well. So that they are still using such kind of devices. And the idea here was then to modularize the main board. And you see here the demonstrator on the right-hand side, where we used certain advanced technologies, namely embedding of components within printed circuit boards to make smaller modules as small as possible. So to outsource the complexity from the main board and to make such kind of device then also better repairable, allow for reuse of components, enable refurbishment then as well. So this has been our approach here, instead of a monolithic printed circuit board. But if you look then at the carbon footprint, it's a bit similar to the Fairphone example, but actually in the end much worse. All what you invest here compared to the standard design in terms to make this device or this main board more modular is an additional investment then also in carbon emissions, for example. So there was the idea also then to make the main board a bit less complex, so to go down from 6 to 4 layers, which saves a bit then on the carbon footprint here again. But the printed circuit board assembly as such of this modular built device is significantly higher than it was with the standard design before. And the problem now with this particular device is it's actually pretty long lasting. There are few failure rates from the field, if at all. So professionals stick to this kind of devices. They're used to it. So they are easily for 10 years or so in the field without failures and defects already right now. So the repair case, also the reuse and refurbishment case, doesn't really play so much a role. So it's hard to find an appropriate scenario here. So which means here it indeed bounces back, this kind of modularity, and it's a perfect technology demonstrator, but it's just the wrong application to implement such kind of modularity. And this is already a pretty important lesson when you are talking about circular design and modularity to enhance repairability, also recyclability, for example. So unless we are talking about Lego, optimal modularity typically is not maximum modularity. So it really has to be mirrored then by your individual case, by the later use phase. And that's why a life cycle perspective is so important. What will happen to this device throughout the life cycle? And I have a third example from our own projects here for you. For many years now, we are working together with a small Irish company. They are really keen to develop sustainable mobile devices, PCs. Also, they frequently use then wooden housings for that as kind of sustainable material, but it's also easier to process for SMEs. So it has some processing advantages here as well. A lot of mono materials otherwise. So a display and cover glass are not fused. Only 6 screws to disassemble the housing. Use a replaceable battery, so such kind of things. Also some kind of rather old-fashioned VGA connector, Ethernet connector here to make it play then also with more old-fashioned devices, so that you don't have to throw away your old-fashioned peripherals. And that you can keep your computer ecosystem in life for longer. So, but also all this comes at a certain environmental price, and now and then I just as a reminder place then an iPad on top of this D4R tablet here, which is designed for circularity, and you see all of a sudden, not extremely surprising, the material consumption for this D4R tablet is much higher, much more resources go into it. It might be better recyclable when it comes to the metal parts here, separation of it, but the initial investment in terms of in terms of material is significantly higher right from the beginning. And also wood is nice as a material and comes at a low carbon footprint, but it's actually in the end, it would be a mess for recyclers. They are used to recycle plastics and wood, so that they are happy to have gotten rid of the wooden housings of TV sets, of the old CRT TV sets. So which always was a problem then for plastics recycling also. Now with this apparently sustainable solution. If it's not separated properly upfront, then this wood will be again a kind of problem for plastics recycling here. And in that sense, it's I pretty much like this kind of product and approach, but there's also quite a lot to learn what can actually go, well, maybe not go wrong, but can bounce back in terms of a life cycle perspective. And that's what you see then when you go also through some kind of life cycle assessment with realistic assumptions for the use phase, for example, for the end of life as well. So now I blamed ourselves pretty much for design examples which are not all that shiny once you have looked at from different perspectives. So this now allows me also to be a bit critical about some other examples from others. We had this INEMI learning series here with a fabulous team from INEMI and from industry, from IPC as well, set up. The idea actually was to bring to a webinar a broader number of excellent cases from industry to learn from each other. What are they doing about eco-design principles with a view at circularity in particular, as a circular economy? What are their solutions? What have they learned? What is the journey they went through when implementing circular design? And in that way, we had here over a few months then 6 such sessions. All the recorded sessions are still available through the INEMI website, here also on YouTube. So I just encourage you to have a look, to be inspired about what they are telling. But I also now go the fast track and will pull out some of the examples we have seen here and comment on them from, again, a life cycle perspective. Some of the statements the presenters made, and it already points at some interesting, but partly also critical points. Maybe the last one here from Google: what can we do? We can close the gap. Chemical recycling, mechanical recycling, plastic tax, collection, take back. Yeah, this is the more conventional understanding of what circularity is about. But if you recall what I said before about the recycling processes, it's not a game changer for the industry in that sense, that life cycle impacts are drastically reduced through just better recycling. The essence is really in longer product lifetimes, actually. Fairphone, pretty good statement. Sometimes it's surprising what can be done when someone asks for it. Feel free to ask. And that refers specifically then also asking the supply chain, asking other stakeholders. Because what we learned from this series as well is that circular design, the circular economy, is much more about communication than the conventional linear economy, which is also built around a lot of communication. But here, really, also the communication has to go in loops, and you have to discuss with your peers, sometimes your recyclers, which might become then your material suppliers in the end again. So this is indeed then tricky, but the Fairphone example here is then also, well, there's more knowledge around, more willingness actually to get involved here as well. So one of the examples, we had Samsung here, also explaining their journey when it came to improving the packaging concepts for the Galaxy phone series. So from year to year, from generation to generation, they got rid of plastics, certain inks, shrinked the package as such. And the final move then here to get rid even of the external power supplies and some other accessories, which is actually the major step. So just producing less electronics here. All the rest, the packaging stuff, is extremely important to do. but it doesn't improve your life cycle assessment much. If you would have a look at the life cycle assessment results and you mingle around with packaging, it's a minor thing actually to do. So your main focus should be somewhere else, but improving the packaging nevertheless is also important. So there's a lot to learn from that as well. And what is also important here is that it's a rather long process. So it's really a bit difficult sometimes to spot what are actually here the differences. But from year to year, or 5 years here, 5 generations, these changes are implemented. Circular design is frequently not about a revolution. It's frequently indeed rather about incremental changes over time, learning from these changes, see what works, and doing it a bit better than in the next step. So this is how it's typically then implemented in large companies. And several of them really set off from very comprehensive life cycle assessments here. And a shining example is definitely Schneider Electric. Here they are doing a lot of work on life cycle assessments, publishing these results, but also convincingly made the point that this is not about PR mainly, that this is also about internally learning about the product, the design, what can be improved, what should be improved, how to communicate then also internally and with the supply chain. So they definitely are doing a really brilliant job here. And it's really a pleasure then to listen to their recording from the webinar. Others are struggling a bit more. Hardware optical, so backbone of the internet, infrastructure equipment, here optical components. But the point is with such kind of infrastructure equipment, when you go through your life cycle assessments in the various impact categories, you notice it's always the use phase here, which is really dominating. Dominating use phase on the one hand, which makes energy efficiency extremely important. In particular, as data traffic grows tremendously in the internet, it's important to increase further the energy efficiency. And the technology is actually there, has to be implemented. This is a sector where rapid changes is taking place actually, and where you would create some kind of lock-in effects, indeed, if you would keep such kind of equipment in use for too long. So they were really then struggling to make a point on circular design here, because it just doesn't make sense on the one hand to reuse many of their components, because efficiency has progressed further. And so their last resort was then also hopefully increasing then at least the recycling of this kind of infrastructure equipment. So there are certain product groups where too much circular design doesn't necessarily make sense. And this is then also here a somewhat interesting point coming back to this slide. Conventional linear economy is typically one-dimensional. If we talk about less innovative markets, stable, mature markets, somehow it becomes two-dimensional as we see it here, then coming back in certain circles. But if we are really talking about highly innovative markets and segments, it actually becomes a three-dimensional thing, because once you went through your one of these cycles here, which takes time, extended lifetime, then after a few years maintain, repair, upgrade or so, and you try to come back then here in the loop in the same phase, you will see that in the meantime technology has progressed and advanced so fast that your old technology doesn't fit anymore into these cycles, into this life cycle actually. So here then the wisdom, you never step in the same road twice, fits quite well to this kind of circular economy challenge here and for these kinds of technologies. And this is important to know, not to create here too many lock-in effects. Sometimes it's indeed better to get rid of inefficient older equipment. I made the critical point about the Samsung packaging improvement, which is great to do. They have another really great approach. So the Galaxy Upcycling program, I would rather call it repurposing program, because all this is less about recycling also. It's really with the smartphones we have in our hands, we have small supercomputers. And even after 3-4 years, they are still supercomputers and can be really used for a tremendous number of other pretty good things, where you need then a camera, maybe some kind of Wi-Fi connection, the radio interface at all, some memory also. And they set up then here an interesting program they told us about. It's also on their website. Then you can find it there as well. So no secrets here. Actually, some kind of innovation hub, exchange with makers. So what can be done with these old devices? What could be then a good secondary application for that? And then partly also internally with their innovation teams. And they came up with some really good cases here. One such thing is then making use of these old Galaxy phones then as a camera for diagnosis in developing countries where they can't afford then extremely sophisticated equipment. But here for eye diagnosis, it works pretty fine and can really help then in certain countries to give better access to medical treatment and to diagnosis beforehand. So this is, in terms of sustainability, it's great, because it makes a really good point here. But the other thing is here, it's also then a kind of rebound effect. We are using now these kinds of devices for applications where no such technology was in use. With this one here, I said it's a pretty good sustainability case. But there are then other exemplary cases, a remote aquarium control system to feed the fishes automatically when you're somewhere else. Also, this is really something which then bounces back a bit in terms of technical add-on. There are hardly any cases where then these repurposed phones really replace some other kind of existing technology or product. Therefore, this is then a bit critical in terms of the rebound effect, to be a bit critical here. Pretty good example from Barco. They are developing then cinema projectors, for example, among other stuff, but this is one of their main businesses. And they are really doing then really a great job in developing those in a modular way, also to make them easier to repair, replace certain parts, made for upgradability. So if a more efficient technology is out there, so it could be built in to a certain extent to take care of that. So this is something which actually is frequently then also seen in the business-to-business environment, less so in consumer markets. But here, indeed, the question is, what can the consumer market maybe learn from such kind of business-to-business examples? One such learning case would then be here, for example, the Framework laptop, which is to a certain extent a fabulous product. So this one then really being customizable. What is great, I told you about the carbon footprint of, in particular, the memory storage and such kind of devices. So here it's modular again, in a certain extent, that you bring your own memory. If you have RAM or memory bar already from your old device, was removable, then you can build it in here. So no need for a new one if you're still fine with the old one. And so this is really great. Exchangeable port modules here. So depending on what your connectivity needs are here, so very repairable. So this sounds pretty good. Definitely, this comes also at a certain, let's say, environmental overhead at first, because you need to build in more connectivities, more connectors here, again, sub-housings, etc. But most likely, this is also a case where it then pays off easily over longer use, over replacing parts, by upgrading then memory, SSD, if your need goes up here. So in that sense, these are all the examples I had here for you. There are many more embedded in the aforementioned videos. And if you have a look now at the various strategies from the manufacturers, well, what becomes a bit evident, we were looking for circular design examples, and what we found were mainly end product manufacturers. Not very surprisingly, they have most control then over the product design, and can make things modular, most control. So there are no or hardly any companies involved here in this, which are squeezed somewhere in the supply chain, will struggle hardly then to make their way into some kind of circularity approaches. What was surprising, what we didn't knew before, is that here at least half of them really applied life cycle assessments, so conforming to the norms, to the ISO standards. Then also that they really want to know that what's going on here, and to get the figures right, although it's no legal requirement to do that. So sometimes it helps for environmental product declarations, of course, but they all went this route because they saw the benefits of getting the figures right, having some credibility in it, and building then decisions based on this. So this was really good to see. I would say most of them were pretty satisfied with it. One example was Barco. They said then in the end, well, not enough guidance from the LCA. They came up with their own scored approach here as well, to rank certain design aspects. And they even made this then open source. So on the Barco website, you even will find their checklists, which they use and how they apply their scoring system to their products. So pretty good to see it moving in this direction, and we see more and more companies in the electronics and the ICT sector going this way. And well, wishful thinking is then also that it's picked up by policy. And here then on a side note, what is going on in Europe currently, because here we have been then involved as well in supporting the European Commission to develop and draft legislation on eco-design and also an energy label. So this is here somehow the design. If you are now and then in Europe, you might know that it looks like this over here in the EU, with these energy efficiency classes A to G. But now the latest proposal from end of August for smartphones and tablets is also to populate this label then with further indicators, namely here drop resistance, repairability, battery cycle count, IP glasses, so water and dust ingress protection here. And this is pretty much inspired by the life cycle impacts. So actually, I would say this A to G scale, the energy efficiency is a bit should be less the focus, because energy use is not the main environmental impact when it comes to these devices. But on the other hand, the less energy you use, the less frequently you have to charge the battery, the less frequently you have to charge the battery, the longer life the battery will have. So which means this also increases here energy efficiency, the overall lifetime of the product. So and this is just the most important thing here. And then down here, these three IP classes, battery life cycle and drop resistance, are reliability aspects. If your product does not fail, that is gives you the best chance that it lives longer. And one additional aspect here on repairability: if it really fails, then at least that you can make it repairable. So all these targets now, although it's called energy label, it really targets at longer product lifetime, and this is the main lever here, really, to improve the life cycle impact. So in that sense, LCA evidence, if not even a full LCA, also is reflected somehow in the way policy is made currently in the EU, which is pretty good to see. So this actually brings me here to the conclusions regarding circular design. First thing, you do not need to start from scratch. There are some really pretty good awesome examples out there how to do circular design. What are approaches? What are ideas? What are the journeys also the companies went through over time? But I really strongly recommend not to copy and paste. We didn't find two cases which are the same in the end. You always have to see how it matches for your product segment, for your market segment, for your stakeholder interest, how much control you have over the design, what they're doing in-house, how much integrated you are as a company. In that sense, for example, Samsung is in a great role because they have most of the relevant technologies actually in-house and have a lot of control over that. So this is rarely the case with others. So you have to see how to do that. Sometimes you might be not very patient and say, well, let's go for a circular design all at once. This might work and works pretty good for some niche markets, such as the framework laptop, the Fairphone example as well. So where they build a new market around these kind of modular products, sustainable products, hopefully, in the end. But of course, to go this way, their market share is small compared to the large players. So if you're a large player, if you have an established business, mature market share, it's rather a step-by-step transition process to go circular. We have seen that with the example here from the packaging, the Samsung case, but it's also same. We went through several projects implementing recycled plastics, only recycled plastics in electrical and electronics products. And it's a year-long journey, really, to get the material right, to qualify the products, to adjust the product designs, to incorporate recycled plastics, to make the tools for that, to qualify the material, to bring back enough amount of material into this loop. So this all really takes a lot of time, and it's not only technical issues, it's also communication, material flow, logistics in the background. So be prepared to go through it step by step. What definitely helps is a circular perspective. Life cycle assessments can be of huge benefit here and are a good starting point to get the figures right, to find your hotspots and to have a basis for your creativity. What can be improved, which directions you might want to go. But in the end, also be aware of rebound effects and trade-offs. So the trade-off example I've shown you is the modularity, which can bounce back if it's not implemented properly, or if the later application product use doesn't work as you planned in your design. So this has to be thought through as well. In that sense, it's somewhat intellectual challenge to address this also properly. But I'm sure you are in the position to do that and to absorb that properly. So this actually brings me to an end, and I'm now happy to get your questions either on the eco-design and circular design examples or on my family, whatever suits you most. Thanks.
Thank you so much, Karsten, and welcome Tom Withridge, who's our Senior Sustainability Advisor, who will ask your questions of Karsten. Welcome, Tom.
Thank you, Holly, and thank you, Karsten, for an outstanding presentation. Obviously was very interesting and has generated several questions. So I'm glad we have plenty of time for some answers here, and I'll just start picking some from the list that is in the question and answer box. So the first one is, what are some materials that are impossible to recycle or reuse, and therefore have to be sent to landfill or incinerators?
Well, any kind of composite material is definitely tricky. So therefore, keeping things and materials separate, not gluing everything together is, from a recycling perspective, of course, much better. But at the end of the day, it's then, well, if you're talking about electronics, the printed circuit board assembly as it is, it's difficult to recycle. So the recycler will tell you, and he's pretty right, that he can get most of the value out of it again. But this is then the copper, precious metals mainly, nickel maybe, tin, zinc. So most of the material, and also what is discussed as critical raw materials in these printed circuit board assemblies, is lost. So it's so silicon anyway, also the silicon in the glass fiber, the epoxy material is gone, tantalum is gone, iron most likely will also not get directly back, all the ceramics, aluminium, which have then aluminum ceramics in the capacitors, for example, all this will be gone. A lot of material will be gone, which makes it, from a raw materials perspective, really tricky to deal with printed circuit boards in particular. But well, recyclers are looking at where they can make the money with, and they care then about 90% of, let's say, the value. The remaining 10% are lost, even if it's rare materials, but we frequently call them also spice metals. So because they are in there, they're extremely important technology-wise, but in so minor concentrations that it's really hard to get hold of them again at end of life, if at all.
Well, with that in mind, we actually have a couple of questions that relate directly to what you just said about the difficulty of recycling things like mounted PC boards and so forth. The first one is, has there been much consideration of reuse of chips themselves for other applications?
Well, actually, we had that in the one project where also Fairphone and the digital voice recorder and the D4R tablet was involved. We had another activity there, really, where a partner from Poland then desoldered chips from the printed circuit board, so from used printed circuit boards, reworked them, established a process, partly industrial scale, partly lab scale, really to reball the memory chips, to bring it back on the board, to have some quality control of it. So there are some activities going on, and actually in the times of a chip crisis, I think this is even more asked for than I'm sometimes happy if I get a chip, even if it's then harvested from an old device. So just to have something to build my product or my prototype or whatever, my demonstrator around it. But this is really then challenging because it's hard to do on a really large scale, on a huge scale, because you need some kind of quality control. The processes are necessarily not there, and you need also some kind of a stable inflow of used devices of the same kind, because only then it makes sense to harvest it and to build a new product around these, for example, old chips. This is then the extremely challenging logistics, which we always see when we're talking about the circular economy. That's, well, keeping things in the circle, and the circle should be equally populated somehow. This is something different than a conventional supply chain where I order 1 million components and the supplier will tell me, well, I can do this next week or in 3 months or in 1 year or so. But I can be pretty sure I will get it. You can't be that sure, or you have to establish your processes, your circles, then if you rely on this then in a circular economy. And this is why I would say, so there are some, let's say, Far East approaches on making this work properly somehow and to bring it back into some kind of toys or whatever. But on a more sophisticated level, to make good use of these components, which would be excellent in terms of reducing the environmental footprint of the electronics industry as such, because that's where it really matters. So that there are hardly any examples for that except maybe then also for the industrial sector, where then older printed circuit boards from old computers, steering boards, so are partly in use then for machinery to refurbish them and equip them, but no way in the consumer business, I would say.
So it sounds like, in addition to the issues around reusing them, an infrastructure needs to be built up so that there's a good, solid supply of used material out there to draw from, a good base of it to use to meet needs. Interesting.
Yeah, I fully agree, and it's also a bit not to frustrate anybody, but it's also a hen and egg problem somehow, because when it's, for example, about recycled plastics or recycling plastics, so the recycler says, well, I'm happy to increase my capacity, but only if somebody tells me he or she will take a huge amount of my material then over the next few years and gives me a guarantee for that. And the OEM says, well, I'm interested in the material, but I will not give you a guarantee that I will absorb what comes out of your recycling plant, because first of all, I need to be sure about the material quality. Material quality might change over time, because your input to the recycling plant will also change over time. So there needs to be some kind of tight control. But I also will not ramp up my product portfolio with recycled plastics as long as I cannot be sure that I will have a stable and sufficient supply over the next years. So there is a certain win-win situation, but there needs to also be some kind of trust building in between, and finding the same terminology when talking about material, because material for a recycler is something totally different than for an OEM who wants to qualify the material for a certain application purpose and so on. The recyclers frequently is just not prepared to talk the same material specification language.
Yeah, I think one thing that's often lost in this discussion is we are talking about an economy, not just being circular. There is an economy aspect, and that goes directly, I think, to your comment there. And with that in mind, there's another question that fits along with that whole economy idea. And it's, while planned obsolescence exists in the production strategy for many electronics, how can we be optimistic that circular economy of electronics will help reduce environmental impacts in the long term? And have you considered this in your research?
Well, definitely. So planned obsolescence, in case it exists, is a critical thing, and also heavily politically debated. So I personally have some doubts that something like planned obsolescence really exists. Of course, manufacturers somehow plan their products for a certain lifetime. They need to have some kind of benchmark. So how long do certain parts need to last to fulfill certain requirements? So if that is the understanding of planned obsolescence, then there is planned obsolescence. But well, in some research which was going on, we others also looking into this issue, I think there was hardly ever a case where somebody really could say, well, this is really a case of planned obsolescence, where the lifetime is limited on purpose by some kind of technical or software, could include also software means, to reduce the lifetime and to sell more of the products. So the regulators, also policymakers, are a bit skeptical about this, if you can trust then really the manufacturers on this one, and if there might be some kind of planned obsolescence also. So this discussion spiked a few years ago. It's not so dominating anymore, I would say, at least not here in Europe. But policy is reacting to it with exactly this kind of requirements I've shown here with the EU energy label, now looking at certain durability requirements, which includes reliability, but also repairability, really to keep things alive for longer, in use for longer. And with the ultimate purpose really to bring down the overall life cycle impacts. But the flip side of this is that should be kept in mind if products are used for longer, that fewer products will be sold somehow. So because it has to be reduced somewhere. And this is then indeed the political intention to have less need of producing new products. Which means for the manufacturers, if they build their business model around selling every 3 years a new product to the same user, then maybe going more into the high value direction, more higher quality, maybe building a business case then on around refurbishment, around spare parts provision. So just as Framework, for example, is doing that, they built a complete ecosystem around that, that they do not only sell the initial laptop to the end user, but over time then also the other parts which he or she needs for repairs, for upgrades, etc. So in that sense, it's a more continuous business relation to the same customers, and this is not too common, I would say, in the consumer business. Much more in the business world, but less so in the consumer world.
Okay, thank you. So on a similar topic, when we get back to the idea of reuse models, then, have companies with low impact reuse models found additional business from those new business models?
Well, you really need to focus your business a bit on reuse. So it depends a bit. There are also in the ICT sector. In the meantime, it's an extremely fast-growing segment of refurbishers in the market. Really getting products then from businesses, refurbish them, bring them back, typically then to end consumers, partly also again back to businesses, or some buyback refurbishment businesses also from consumers. So that they gain actually in market share, and for them it's working perfectly. So you can build such kind of product model indeed, and there's also a huge demand in certain used devices. So you can make your margin, but it's a different kind of business than what you're used as an OEM producing new products. So you need to get used to that, maybe tap into some kind of test markets to see what works where, and then absorb this over time in your own business model.
Okay. So have you looked at government or industry association policies that could improve the logistics of circularity?
Well, the associations can play, of course, a pretty important role. So just as we had it here with then INEMI, but also IPC jumped then on that train, because they're all just looking into what works and what doesn't work in terms of circularity. And frequently there was this need raised to exchange on success stories, but also the wish to learn more about what fails, what does not work out. So because then others do not trap in the same problems. So the latter is a bit less the case. This is why I provokingly try to pinpoint here in the presentation then these aspects where something might be seen a bit more critical maybe than it appears at first glance. This exchange is super important, because circularity means a lot of things which are on your table at the same time, and you need to sort it out. You just usually don't know where exactly to start with, what really to improve, and therefore to hear from others, hey, what did they do? how far down the road that they went with their approaches is important. And here is where associations really can play an important role to facilitate this exchange. But similarly, the governments, so that they, for them, of course, it's also a bit critical then not to interfere too much with, let's say, the competition. And to push individual companies, individual examples, but with certain awards or making the policy environment more favorable for those who invest in more circular products, circular devices. This is helpful. So public procurement has an important role here to play. We have this currently in a piece of legislation in Germany, for example. Then for the governmental bodies also, that they also should consider in their purchasing decisions, then if the same stuff is available as reuse, as remanufactured equipment, to factor this in their calculations. So this is something where then governments and authorities also can make a huge push towards more circularity.
Okay, and for our last question, it's something that steps aside a little bit from the usual carbon footprint look, but it seems that some of the rebound examples are creating additional social sustainability. Has this been taken into consideration?
Well, I picked out this example. So definitely. So there are so many social improvements which you can gain through more and better digitalization, by connecting the people by digital means. So of course all this great. So also smart farming examples, something like this could have huge additional benefits. It only frequently comes also at the expense of just producing more of these electronics. This has to be outweighed, of course, to a certain extent. In the end, it's extremely difficult to balance social benefits against environmental implications. That's why this reuse example, repurposing example of the Galaxy phones, I don't want to criticize it too much. This is really a shining example, but there are, I would say, many gimmick-like applications which came up then for used smartphones, where I would say, well, this is not really what mankind needs here as an application. So this is really a bit over the top, and it's rather as some kind of gaming feature rather than really a benefit in whatever sense. So, but for some, gaming is extremely important. So, well, who will judge here? What is needed and what is not needed? Just bringing then the environmental domain on the table is then really important to get the figures right for others, then to make the decision if they want to go the social way or they cut down on the environmental impacts. On the other hand, this has to be decided on a different level. Yeah.
Okay, well, thank you. And with that, on behalf of everybody, I'd like to thank you again for this really interesting and informative presentation. And with that, I think we'll wrap it up.
Yeah, thanks as well. Take care.